Hello everybody. Today we are going to see about how the alpha beta pruning algorithm works. Where this alpha beta pruning is used means it is used in the adversarial search like problems. Okay, what does it means adversarial search is the one there will be a two play game, that is two players will be playing that games. So you have to construct a game tree in such a way there will be two players, max and min. Max will be maximizing the scores and min will be the minimizing the scores of the utility value. Okay, so in the alpha beta pruning, to compute the correct minimax decision without looking at every node in the game tree, we can eliminate large parts of the tree from consideration. This technique is called alpha beta pruning. Okay, in the minimax algorithm, all the nodes will be visited irrespective of the value in the minimax value, whether it upgrades the max node value or whether it is a min node value. It does not take into account all the nodes it will be exploring. But in the alpha beta pruning case, we'll prune the branches whichever it is not necessary for the algorithm. Okay, so we here it is using two parameters, alpha and beta. Alpha is the one which is the highest value for the max, and beta is the lowest value for the min player. Okay, what are the steps to be followed means always in all nodes you have to initialize alpha equal to minus infinity and beta equal to plus infinity. And for max nodes, b will be always minus infinity initially, and for min nodes, b will be plus infinity. So always alpha beta value of children depend upon the root nodes alpha and beta values. If any node is there, whether it is max node or min node, you have to maintain three values: b value, alpha and beta. If it is max node means initially you have to assign b with minus infinity, alpha equal to minus infinity and beta equal to plus infinity. If it is the min node means initially you have to assign that node with the b is equal to plus infinity, alpha equal to minus infinity and beta is equal to plus infinity. So terminal node is the one which is the final leaf, which tells whether the terminal node attains the win or draw or loss. Okay, so that utility value, the terminal node, that v, it will be propagating to the parent. So you have to update the parent's value. If propagated v value is greater than current value of max node, then in max node we will be updating b value and alpha value. If it is min node means you have to update beta and v value if it is the propagated value is lesser than the already existing one. Always to explore the children, the parent should see the two conditions. If it is the max node means if v is greater than or equal to beta means you have to beta cut. You no need to explore that child, you can just prune it. If it is min node, the parent is min node and its v value is less than or equal to alpha means you have to prune the branch that is that children you may not explore. Okay, so let us see one example. Here I have given a node. This is the symbol for max. This is max and this is min. Once again this is max turn. This is min. Inverted triangle is min. This is max. Okay, so first turn max, second turn is min, then max, then min. Okay, so likewise now we are going to see how the algorithm updates and the value are propagated. Okay. Now from terminal node 3 is propagated, and this is max node. So what is initially V's value? It is V is minus infinity, alpha is equal to minus infinity, beta equal to plus infinity. So 3 is propagated, and you have to see whether this 3, the current V value, this propagated value is greater. Yes, so you can update. Current alpha is lesser, V is lesser than the propagated value. So you can update that. Okay. So this max node consists of only one child. So that's all. No need to go to any other children, because it has only one child. So you have to propagate this V value. Okay. This V value to its parent. Now initially for this min node, V value is plus infinity, alpha is equal to minus infinity, beta is equal to what? It is plus infinity. Okay. So for this 3 value, what you have to update in min node? V and beta value, and you have to see whether the propagated value is lesser. Yes, it is lesser than plus infinity, so you can update. Okay. Now you have to see whether to explore these two branches, this branch and this branch, that is to explore the children. What you have to see for the min node? Whether V is less than or equal to alpha. 3 is lesser than minus infinity? No, 3 is greater. So no alpha cut here. You have to explore the from terminal node 6. So what is say here? Beta is for the min node, beta is 3. So for all the children you have to update the beta value over here. So here what is this is max node. So B is minus infinity, alpha is minus infinity. Okay. So 6 is propagated. So you have to update, because minus than minus infinity, this 6 is greater. So you are updating this. No children for this, so you are propagating the value of 6. So whether 6 is lesser than this V value and beta value? No. For min node you have to see V and beta. 3 is lesser, so you are not updating it. Okay. So here also no alpha cut. You have to see the this child, this branch also you have to see. So here the initial value for max, this is max node. So B is minus infinity, and alpha is minus infinity. Now you are propagating 9, and yes, 9 is greater than this B and alpha, so you are updating. If you see over here it is max node. Whether you have to explore this child or not means, no, it gets pruned. Why it gets pruned? For max node, if V is greater than or equal to beta, if V is greater than or equal to beta, then it is beta cut. 9 is greater than beta, so this you will be pruning using the beta cut. Okay. So this is how beta cut happens over here. Then 9, the value of 9 is propagated over here, and if you see 9 is not lesser than 3. For min node the propagated value is lesser, means you will update, otherwise no updation. That's all children of this node has been explored. Now you have to propagate this 3 value 3 over here. What is the initial value here? It is max node. V is minus infinity, alpha is minus infinity, and what about beta? It is also plus infinity. So 3 is greater than minus infinity, so we are updating V and alpha with 3. So in all the, this is the best explored option. So in all the nodes beta this alpha will be 3. Here also alpha will be 3. Here also alpha will be 3. So alpha is the best already explored option along path to the root for the maximizer. Okay, so here alpha's value is updated along the children. Okay, now what is here v? So you have to, from this you have to see what is v here. V is here, that is max node. So v will be minus infinity, alpha is 3, and what is beta? Beta is plus infinity. So 8 you are updating for this. Okay, so now you are propagating this 8. What is for min node v? It is plus infinity, alpha is 3, and what is beta? Beta is plus infinity. Yes, so your 8 is lesser than this plus infinity. You are updating v and beta. Yes, now if you are seeing for alpha cut, if it is there, means what is alpha cut? For min node, whether v is lesser than equal to alpha, whether you have to check v is less than or equal to alpha. 8 is not lesser than equal to 3, so no alpha cut over here. Okay, so you have to continue to explore. So now here 2 you are propagating. What is v here? V is minus infinity, alpha is 3, and what is beta here? Beta is 8, because here beta is updated, so children also gets updated. So for max node you have to update v and alpha. Here 3 is greater than 2, so you are not updating, only v you are updating with 2. Okay, and you are propagating this 2 value. Yes, of course this 2 is lesser than, for min node if it is lesser you will update. Yes, v is updated, and alpha also, sorry, beta is also updated. For min node you have to update v and beta. Now here v now is greater than beta. Yes, for min node v is lesser than alpha cut. For min node, whether v is lesser than alpha, yes, 2 is lesser than 3, so here you have alpha cut. Yes, now you are propagating 2. 2 is not greater than 3, so you are not updating, and just you are leaving as such. Now the value for this max node is 3, and this is 3. So that's how we have solved the alpha beta pruning. Hope you have understood. So these things you have to keep it in mind for beta cut and alpha cut. For max node, if v is greater than beta, means no need to explore the children, you can prune. For min node, if v is less than or equal to alpha, means alpha cut. Through that you can prune the branches. Okay, hope you have understood. Thank you for watching.